Hope you all had a nice lunch. Welcome to this presentation on Qt Style Sheets. I'm Girish. I'm a developer at Trolltech at the Oslo office. For Qt 4.2, I did quite a few things. I am the author of the auto-completion framework, using which you can provide completions for line edits, text edits, combo boxes, and custom widgets. I'm also the platform boss of MinGW. MinGW is our open source platform for Windows. I also worked on the desktop integration stuff like the system tray, the new message box API, MIME handling. I'm also the architect of the Qt Style Sheet stuff, which is why I'm here. The agenda for today, we'll go through the motivation behind style sheets, why we decided that we needed something called a style sheet in the first place, the terminology and concepts behind style sheets, and how to use it. I'll show you a demo on how to style using style sheets. Internal to Trolltech, it was never called the Qt Style Sheet project. It was called the Red Push Button project. And it all started with Matthias, who was my manager, about, I think, last December. He came over to me and said, customers want red push buttons. Make it happen. And I had no idea why it was so hard. And I had done some Qt programming before. I never realized that it was actually quite a complex task to have a red colored push button. And to actually understand why it is actually complex, I'll explain how a widget paints itself. And when you understand this, you'll probably know why it is hard to have red colored push buttons. Every widget has a palette. And as you can see, this is something like a painter palette. It has lots of colors. When Qt programs start up, the palette is populated for you. The palette is populated by reading the desktop settings. Well, the palette colors by themselves don't make any sense, do they? I mean, you have a bunch of colors. What are you supposed to do with them? So what we do is we give them some semantics, some meaning. And this meaning is what we call the color role. And for example, if you see here, it says that the white color should be used as the base role. And this means that all text entry widgets, let's say like a line edit or a text edit, should paint its background white in color. And then you have something called the button role, which says that if the widget looks like a button, it should probably use the red color to paint itself. And you also have it for text and button text. Text is a foreground color, which is in contrast to the base color. And the button text is a foreground color, which is in contrast to the button color. So, how does a widget paint itself? In Qt, what we do is we abstract the painting of the widget into a separate API, which is the QStyle API, which you can see over here. What the widget does is that it takes its palette, it takes information about the font metrics, details about its state. By state, I mean the UI state. For example, the mouse can be hovering over a button, so in that case, it is the hover state. The user might be pressing the button, so that is the press state. So it takes the state, the text. For example, if you see there's the cancel. So cancel would be a text. It takes all these details, puts it in a nice little structure, and passes it on to QStyle. And QStyle takes this information and draws the button. An important thing to understand is that QStyle completely controls the painting of the widget. As you can see here, the one above is actually the plastique style. The plastique style has subtle rounded corners, but if you look at the Mac style, it has more prominent rounded corners. Yep. But same information provided to QStyle, but the output is different. That is what I'm trying to say here. And here's what I started doing as soon as Matthias told me that for the push button project, right? QPalette pal access the buttons palette, get the button role, set it to red, set the palette back, and it worked. What is the problem here? And here's the problem. When we move on to more complex widgets, for example, we have a combo box here. If you look at the plastique style, the combo box actually looks like a button. And if you look at the window style, it actually looks like a line edit. And so when plastique style paints itself, it is going to use the button role. And when the window style is painting itself, it's going to use the base role. So let's say if you want, I don't know, a red color combo box, which role do you set? It really depends on the style. Another important thing to note is that the style is free to ignore everything. Whatever information is passed to the style says, hey, I know better. This is how it should look. For example, if you look at the OK button there, even if you passed it red color, it doesn't care. And this is more to be compliant with the system style. For example, if you take Windows XP, it has no concept of a red color push button. And what does it do? Whatever colors you provided, it just ignores it and paints it its own way. So that's the frustrating experience which probably most of you have encountered. It sometimes works. Like for me, I started the project on Linux. Plastic honored the palette. It was the button color. It worked fine. I ran the same program on Windows XP. It doesn't work. And a problem here is that color roles, by definition, are dependent on the context. It really is decided by the style, how a widget looks. And it is actually quite hard to get it consistently right across all platforms. And here we see that for the background, to set the background, line edit uses base, like I said before, and the button uses button. Another frustrating aspect, if you have tried writing a QStyle, is that it's C++ code. If you want to change pixel metrics here and there, if you want to modify, make small adjustments, you'll have to compile C++ code, you'll have to test it, you don't like it, you'll have to compile it all over again, and the cycle iterates. It can be quite a tedious task. And of course, if we want graphic designers to actually style your application, there's no way they are going to code in C++. So this is the primary reason why we started developing QStyle sheets in the first place. It allows simple customizations of foreground and background. It provides style guarantees. If you want the button to be red, it will be red regardless of the environment and the platform you are running it on. As I developed the initial project was the initial prototype which I had was it would analyze the palette. It would say, okay, you want a red color push button, but this is the Windows XP style you're running on. So I would just render it on the Windows style. And the Windows style is actually pretty popular in honoring the palette. But the problem is that how many of you here have seen a red color push button on the Windows style? Can you please raise your hands? Okay. 2 of them? Okay, you just have to take my word for it that it's just downright ugly. What we decided is that we should also allow complete customization of the widget's appearance. What are style sheets? Style sheets are basically style strings. It's not C++ code. It's very similar to Cascading Style Sheets. As many of you know, Cascading Style Sheets is something on the web world, and it is optimized for text and not for the world of widgets. We just borrowed the best practices from Cascading Style Sheets and adapted to the world of widgets. We also want to make sure that style sheets are scalable. What I mean by that is that the sizes of widgets differ. This is not just about taking a pixmap and just putting it on a widget. If the widget runs on a different desktop, it might have a different size. The screen might have a different resolution. It doesn't look good. So we need to make sure that the images can be scaled in a suitable way. And for that, we borrow a concept from CSS3 called the border image, which I will go through in the future slides. It allows interactive UI development. You can just start up Designer and you can start styling away. I have a bunch of slides which actually explain CSS and all the gory details of CSS and the cascading. I would like to have a poll on how many of you here are aware of CSS, are comfortable with the CSS syntax. Can you please raise your hand? Okay, quite a few. I would say 75%. So I'll go through these slides pretty quickly so I don't bore you too much. You will notice that QStyle sheets and CSS are very similar. Here's a style rule. Very straightforward. We know what it does. It says a push button should be of the color red. No ambiguity there. Just some terminology in place. The stuff before the curly braces is called the CSS selector. The stuff inside the curly brace itself is called the CSS declaration. And color is the attribute, red is the value. That was simple. A style sheet is nothing but a bunch of those rules. So here, what we have done is taken two style rules and put them together. And you can just take this and set it on a widget. What this basically says is that a push button and a checkbox should have the background color to be magenta. And a radio button and a checkbox should have the color gray. Many of you would find it surprising that there's something called spacing. What does that do? Like I said, we adapted CSS to the world of widgets. Spacing is a property which is specific to QStyle sheets. And what it does is it determines the spacing between the indicator of the radio button or checkbox and the actual text. So all you need to say is the spacing needs to be 8 pixels and there'll be 8 pixel spacing. We support the whole range of CSS 2.1 selectors. For example, if you take the first one, it says Q push button color is red, which is called the type selector. And it's important to note that when you say Q push button color is red, it also applies to your custom widgets. So if you have my custom push button, the first rule actually applies to my custom push button. But if you want to have a style rule which says, I want this rule to apply only to Q push button and nothing else, you use the second variety, which is dot Q checkbox, background color is pink. So this would apply only to a Q checkbox and not to, let's say, a my custom checkbox. And then you can also use the ID selector. The ID selector maps to the object name of the widget, which is basically Q object name. We have the descendant selector. The rule basically says that all radio buttons inside a dialog should have the spacing 10 pixels. And the last one is a very interesting one. It says that all the checkbox with text falafel should have the font size 14 points. And the interesting thing here is that you are actually testing for the value of a property. And this property is text. It can be any Q property. It can be just about any Q property. So you can say Q combo box editable equals true. I want it styled this way. So all editable combo boxes would look in a certain way. Pseudo states. We say when you hover, it has the colon syntax, as you can see. The first rule says when you hover over a push button, the color should be red. The next one is more interesting. You can actually combine pseudo states. You can say that when the checkbox is checked and when it is pressed, I want the color to be pink. And there are a whole bunch of pseudo states like checked, disabled, enabled. It should be pretty obvious what they mean. The CSS box model should be very familiar to most of you. 4 rectangles, margin, border, padding, content. Margin is always transparent. The border is the area where you would draw the frame. Padding is spacing between the border and the content. The content is, let's say, a text or an icon, depending on your widget. Standard CSS properties, nothing new here. We support margin, border, padding, background, same stuff. Minimum width and minimum height is interesting. You can set the minimum width and the minimum height of a widget. using the CSS properties width and height, min width and min height, I mean. An important thing to always keep in mind is that width and height refer to the width and height of the contents rect and not of the entire box. And this is very often confused. Border image. I mentioned before that border image is the way we make stylable, scalable styles. The concept is really simple. Though I mentioned that it is a concept borrowed from CSS3, it's actually a pretty common concept. We take an image, we cut it into 9 parts. As you can see, to cut an image into 9 parts, all you need are 4 parameters: the left cut, the right cut, the cut at the top, and the cut at the bottom. What are we trying to do here? Basically, what's happening here is that we are trying to isolate the corners of the image. And usually, in the corners of the image, you have a nice rounded area, and you don't want to scale them. So what you can do is take an image like this and easily stretch. So only the edges actually scale and stretch. Here's an example. This is the standard CSS3 syntax. You specify a URL for the image. You specify the cuts. This is the formal notation below. It says TRBL, which is top cut, right cut, bottom cut, left cut. And what we have done is said that 3, 3, 3, 3, all of them are 3. You can also specify the stretching modes for the edges. We specify that the horizontal stretch mode is style and the vertical stretch mode is stretch. What does that mean? We'll see in a second. So here's how we cut the image. And this is what we get. As you can see, horizontally, it is styled, which was the first argument there, and vertically, the pixmaps are stretched, which was the second argument. Here's a real-life example. This is what you would provide as the image for a button. You cut it into 9 parts, and now they're scalable. As you can see, what we did to the image is we isolated all the rounded corners. Cascading. Cascading is a complex topic. Whole books have been written on them. I'm going to attempt to present it to you in like 5 slides. Let's see how it goes. Style sheets, CSS, as we know, can actually provide a cascading mechanism. Style sheets can be from varied sources. It can come from the browser. It can come from the user. It can come from external style sheets. It can actually be embedded inside the HTML itself. We have something similar. You can set a style sheet on the application, which is Q application. You can set a style sheet on the widget, or its parent, or its grandparent, and so on. So for example, we have the application style sheet, which says Q line edit, color should be red. We have a style sheet on a dialog, which says that hash my line edit, color should be red, background should be yellow. And we have a style sheet on the line edit itself, which is the widget itself. How is the effective style sheet computed? Yeah, I'll explain it in the future slides. Yeah. First, let's not get into cascading first. Let's just take a simple style sheet. A style sheet, as we know, is a bunch of rules. How do we calculate the effective style rule? Selectors have more weights. Selectors, for example, if you look at hash my button, you're probably trying to refer to a very specific object. So it is more specific than something, let's say, which has a pseudo state, like saying enabled. It is more specific than something which tests for an attribute, and it is more specific than a simple element name. For example, let's say we have the style sheet below. We say hash my button, color is red, dot Q push button, color is green. So the effective color is the first one because it is more specific. What happens when rules have the same weight? For example, like the one here, we have Q push button, color is red. Q abstract button, color is green. The latter one wins, which is Q abstract button, color green. This is a bit counterintuitive. You would think that when I apply the style sheet on a push button, Q push button is more specific than Q abstract button if you look at the inheritance hierarchy, right? But as far as CSS goes, all it cares is about the weights of the selectors, and the weights of the selectors here are the same. So we try to be just conformant with CSS. That's a lot of text. I'll skip that, but let's go to the example directly. It says that my button color is red, Q push button has the color pink and the background white. Weird colors. Anyway, how's the final style sheet computed? The way this works is that first we try to query the style sheet for the attributes and their values. First we query for the color red, and as we can see that there's a rule called my button which says that the color should be red. So that goes into the final style sheet. Then we want to know about the background. The background is not there in the first rule, even though it's a more specific rule. It is not there. So we just pick it up from the second one. So the background becomes white, which is what I mean by style rules are merged. So how is the effective style sheet computed? We always prefer properties. The slides previously discussed only about computation of a single style sheet. Now we have style sheets from various sources. The widget, parent, grandparent, all the way to the top. And then the Q application. Who wins? The widget style sheet is always preferred. This is because it's the most intuitive. For example, if you take Q application, you set the button to be red color, but let's say you go inside designer, you take a specific button and you say its color should actually be green. What should happen? Its color should be green. I'll skip the text there. It's not very interesting. But this is what the text was trying to convey. Take an example style sheet. It says that the application style sheet line edit should have the color red, background blue, border blah. The dialog has a style sheet of its own, and the line edit has a style sheet of its own. So if you look here, we want to first query for the color property. We choose the widget first. It doesn't matter that hash my line edit is a more specific rule than the star color :white. We still choose color white because it is set on the widget. So the widget style sheet is always preferred over the widget's parent style sheet, is always preferred over the widget's grandparent style sheet, and finally the Q application style sheet. We then try to query for the background. The background is not there in the line edit style sheet. So what we do is we go to the next level. It's there in the dialog. We pick it up, put it here. We want to query for the border. Border doesn't exist on the line edit or the dialog. We go all the way to the top, and we find it in the Q application. Subcontrols. Subcontrols is a concept that is entirely new. It has nothing to do with CSS. It is something that we created for styling widgets. If you take a button, for example, a button can have a menu. When the button has a menu, it normally draws a small triangle on the button, which says that if you press it, a menu will be popped up. What do we do to style these small elements? Which is nothing but a subcontrol. Subcontrols are parts of a complex widget. For example, if you take a combo box, there's a drop-down button in a combo box. It is a subcontrol. There's a menu indicator in a push button, and there are also buttons of the spin box, which are again subcontrols. For those of you who have been following CSS3, which is a draft standard, there is already a syntax for : which you see in the example below. It refers to a pseudo element, and they distinguish between a pseudo element and a pseudo state from CSS3. Subcontrols have the same syntax as a pseudo element, but have little to do with them. So this is how we say that the menu indicator should be have this image. Subcontrols can actually be styled the exact same way as normal units, like the widget. The widget had a box model, right? The subcontrol can be styled the exact same way. They can have a border image property. They can also have an image property, which is just a fixed map. And they also have pseudo states. So for example, if you look here, we say that when the mouse is hovering over the push button, you can actually change the image of the menu indicator. Subcontrol positioning. As we know, UI designers are quite picky about where all these elements should be placed. Where should this down arrow be placed anyway? Should it be all the way to the top? Should it be at the center? Should it be at the bottom? Should it be at the left side, right side? And the way you control that is using subcontrol positioning. Subcontrols have a width and height. Do you have a question? Yes? Yeah, it will be up in the coming slides. Subcontrols have a width and height. What you basically do is you start out by, it's like a parent-child relationship. The subcontrol says, I want my origin of reference to be this rectangle in the parent widget. So for example, it says that subcontrol, it's better to have an example. For example, this one. What we say is that the subcontrol's origin is the contents rect, and we say that the subcontrol should be positioned at the right center of the contents rect. And here's how it looks. This would be the button. The entire box model is the button. The red colored part is actually the menu indicator. What we did is we specified that the subcontrol origin is the content and the subcontrol position is on the right center side, so it got placed there. This is sort of a concept again borrowed from CSS. We support relative positioning and absolute positioning of subcontrols. To see why this might be useful, think of the case where when you actually press the button, you want the indicator to actually move by an offset to give a visual indication that it's actually being pressed. And this is how you do relative positioning. Straightforward, you say that the position is relative, and then you say from the top, move it by 5 pixels, from the left, move it by 4 pixels. The top and left properties are a bit confusing to use because what they make happen is that the element moves 5 pixels to the bottom. It's from the top and to the bottom. It's the same thing to do with left. It moves to the right or from the left. And this is what we did. The original the red rectangle is the place where we originally positioned it, and then we provided a relative position, and the yellow rectangle got moved. So now you can see that the yellow rectangle actually overlaps the contents rect and the padding rect of the parent element. In a few cases, you may not, if you have noticed in the previous slides, for relative positioning to work, you need to know the width and the height of the element in advance. Otherwise, it's hard to figure out where the element should actually be placed, which is where absolute positioning comes in. Take, for example, the drop-down button of a combo box. When the combo box changes in height, the drop-down also needs to change in height. So its height is variant. What you can do is you can specify the distance between the subcontrol and the parent rectangle, which is what we do here. We specify that the position should be absolute, and we say from the top edge of the parent element, it should be 5 pixels. From the right edge, it should be 2 pixels. From the bottom edge, it should be 5 pixels. So if you look at the picture, it becomes this way. And the distance at the top is 5 pixels. The distance at the left is 2 pixels, the right. And the distance to the bottom is 5 pixels. The image had a width. If you had noticed in the previous slide, it had a width of 20 pixels, which is why it has a size. Otherwise, it would just go all the way to the right of the bottom, all the way to the left of the contents rectangle. Yes? No, we don't support the percentage metric at all. With style sheets, when we develop style sheets, we figured that there are these few properties which people want to change, which are style hints. If you are aware of style hints, if you want to actually tweak a style hint, you will actually have to write a style proxy. And if you have to write a style proxy, you have to actually re-implement at least, I think, 8 virtual functions in QStyle, which is a pretty tedious task. What you can do is we have these magic properties, which are specific only to Qt, of course. For example, you have the message box text interaction flags. It says that the text in a message box can be selected. So you say Q message box text interaction flags. I think it's 5. It's there in the example. And all your message boxes automatically become selectable regardless of the platform. Okay, all's not good. There's a catch. What we released with 4.2 is actually the first version or the first iteration of style sheets, and we focused on what we call the form widgets. Form widgets are what you're likely to encounter in web-based forms, and what you saw in the example, spin boxes, line edits, combo boxes, buttons, and stuff like that. Not all of them are supported. The complete list is actually in the documentation. There's also other stuff like splitters, toolbars, toolbar handles, which can be styled in Qt 4.2. And sorry for the Mac OS fans. And the reason is Mac OS is actually not supported is that internally it is implemented as a style proxy. And wow, this takes time. Let's say you have a line edit, and you just say padding to the right should be 20 pixels. If you see, it actually has a frame and stuff, and it leaves 20 pixels to the right. And you can, if you have seen, let's say like the search button inside Mozilla, you can actually place whatever you want in the small padding rectangle. And you will get this across all styles. So for example, if you run it in CDE, you'll see there's still space. And it has the frame of the CDE style. So internally, it is actually a style proxy. And it relies on certain features of the style. The Mac OS style completely ignores even the basic stuff because they're very strict about the user guidelines. But we intend to fix both these for 4.3. There's a style sheet example as a part of Qt. It's an examples widget style sheet. And the documentation is in easy to remember URL, doc.com 4.2 stylesheet.html. Okay, questions?